team in India, and he is here to help us out with anything. So if we require in session, so you can basically try to interact through chats throughout the session. You can post any query you have, and we will try to answer them throughout the session. Okay. And if you want to like, if you want to interact with us after the session, you can stay like 5-10 minutes. We can stay and we can answer all your queries after unmuting you. So I think with this, I will start with the session. If you face any issue, just post it in the chat. Uh, I might not be able to see the chat, but they from the team will let me know if there is any issue. So yeah. So the first session, so today is the first session for a 2-day series which we are planning to do, right? So in the first session, in the first part of the session, what I am going to do is give you a slight intro of MATLAB and Simulink and what basically MathWorks is. Okay, and in the second part of today's session, we will start with ML, AI, DL basics. Okay, in like any point of time you think you are not understanding anything, you want to ask anything, just put it in the chat. Okay, so let's start with the session. So the agenda for this particular first part is I am going to give you a kickstart of the things, which includes basically tech talks, like sneak peek into the modern industry, right? And how can you get started if you want to start with the things uh, at MathWorks, at MATLAB and Simulink, and how you can do MATLAB and Simulink, like that basics we will cover. Now, what do we have? What do we have as in what MathWorks have, right? Uh, as MathWorks, what do actually we have, right? So we are basically the makers of two major products, two major industry products, which you say see like day in, day out, which are MATLAB and Simulink, right? So many people know us as MATLAB instead of MathWorks, right? But actually the company is MathWorks and the products which we have is MATLAB and Simulink, right? Uh, you use them in your like mathematical competition, maybe in your labs, maybe your uh, department specific work, which can be triple E, ECE, mech, biomed, right? So you may be using them there, right? Now what MATLAB is, right? It's nothing but a programming platform which is used for like algorithmic development, or it can be used for your data analysis, it can be used for your visualization, right? uh, what can you do with MATLAB, right? What you can do is you can develop algorithms, you can create different AI ML models, DL models, neural networks, right? You can analyze your data, you can play around with data, right? So all these things you can do easily with MATLAB, right? What MATLAB basically lets you do, which like other languages uh, might not or might have, is it takes your ideas from research to production. Okay, you can work like with multidisciplinary systems in MATLAB, whether it's a what I can say automotive related product, whether it's a electrical related product, whether it's a uh, any other product, you can just simply use MATLAB for that, and you can integrate things over with MATLAB and Simulink. Uh, what is Simulink? Simulink is nothing but similar to MATLAB, but here you don't have to like write code. Okay, you have blocks. You can simply connect blocks, play around with blocks, and you can have your system developed using those blocks. You don't have to code. So if you are someone, say from mechanical background, say from automotive background, or you're not familiar with coding, right? So I think that in that case, Simulink comes into the picture, making your task day-to-day tasks very easy, right? It's basically a model-based design platform. You can simulate things over here by simply connecting different sets of blocks. Now, time for a little tech talk, right? So, it's basically a how do human walks, right? Uh, that's a little tricky question, right? Can we model this particular thing? Yes, we can definitely do this, right? Actually, one mathematician modeled this in MATLAB, right? So you can see this that from this video that how we walk basically depends on different things. If the person is a male or a female, right? If the weight is heavy or light, how is the nervousness? Is the person happy or not, right? Uh, you can play around with this tool. This is the link which you can find in slides when it will be shared with you. So it's basically a model which has five vector, which has five coefficients v1 to v5, and you can like use that equation to model human uh, motion, right? So it's basically again this complete simulation, whatever you are seeing is done in MATLAB and Simulink, right? So this is one interesting use case which we have. uh, Apart from that, so this is the equation you can see in the bottom. So this particular equation helps you model this complete system of walking. So it has five coefficients. It has v1 to v5. Every coefficient actually like signifies different thing, right? So v1 is simply like stating the static motion, right? Is there some problem with screen? Yeah. So they, I think, is showing you live. Yeah, they will show you the live demo of this particular model. So you can also play around with this particular link.
Yeah, sorry about that. I was actually trying to just share the link, but interestingly, it also opened up a window and
Okay,
started
okay,
showing the
okay.
demo. Okay.
Yeah, cool. Dave, do you want to show the demo now?
It's fine. I have pasted the link in the chat, so if they later
Cool,
on go and want to go and
cool.
interact with it, it should be there for them.
Cool. So, people, you have like chat in the chat, you have the link for this particular model. So you can just go and play around with that after the session. Okay. Just try to follow me for now. It will become interesting with time. The session will become interesting. Just try to stick with it. Okay. So this particular model I am showing you, it basically models the human motion, right? And every coefficient determines different thing. So V1 basically determines the static positions, right? Uh, so it basically tells how this eigenvalue, this particular model looks at rest. Okay. The second coefficient V2 basically dominates the forward motion. Okay. The V3 basically controls a sideway motion, and V4 and V5 defines the vertical motion for this particular eigenvalue. Okay, so these particular coefficients has their individual significance if you try to see. So next, it's also interesting part that uh, are one of like our mathematician Cleve Moller, right? He is very senior mathematician. You can just go and simply Google his name, you will understand. So he's one of the co-founders of MathWorks. He basically produced a 6-minute film which was titled Matrices and Their Singular Values. So it's basically here. And this particular film or video was basically used in a very famous movie. If you can go back and check. Can anyone guess which movie is this? Can you put in chat and they will confirm whether it's right or wrong? Any single person who knows which movie part is this? Exactly, Star Trek, right? So MathWorks, MATLAB has also been featured into Star Treks, right? So it's interesting the use cases you see, right? So moving on to the next slide. Can anyone guess what's this? Can anyone tell me what's this? I am going to play this video. You can just see this video, right? So, can anyone tell? They has anyone answered correctly? What's this?
Not yet.
Okay. Is it that difficult? If you are following the session, is it that difficult guessing what's this? Okay.
So there is an
And
easy answer to this, and then there is a more detailed answer to this.
detailed answer, exactly.
Correctly, Rishi has mentioned that it's a MATLAB logo.
Exactly, right? So it's a MATLAB logo, right? But it actually like didn't come like that any person sit and decided that okay, this will be the MATLAB logo. So there is a very interesting story behind how MATLAB logo was generated, right? So it's basically nothing but it's an eigenfunction of wave equation, right? And again it was generated by Cleve Moeller only, right? He was basically working on some Stanford thesis. That's when he came across a L-shaped membrane, and that's how you can see this complete MATLAB logo was generated. So this is how it was designed, and this is how it came into existence, right? And the colors of this logo basically represents our company's value. So it's a basically interesting story that the logo was not simply designed in a lab. It's basically nothing but it's generated from a wave equation uh, thing, right? So it's interesting in that sense, right? I'm going to play this video. You can see this video. Just try to observe what is happening in this video. Can anyone tell me what just happened in the video? Uh, can anyone tell me what just happened in the video?
I would say any guess is a good guess. So
Exactly.
feel
You
free
can
to
guess
make
it's
your guess. Yeah.
there is no wrong answer here. What just happened in the video? Can anyone guess? Suicide. Okay. Very extreme answer. Any other guesses
My guess
apart
would
from
be that it's trying some dancing, maybe some dance moves.
maybe? What's the frog trying to do? Sure, I can play it again so you can see here.
Maybe it is jumping with fear.
Sorry. Yeah, someone was saying something.
Fear.
Yeah. So what does this frog trying to do? The frog is escaping, maybe. It's been kept in jail sort of a kind of a thing, and it's trying to escape. Maybe it's also
There's a good
possible.
answer from Nabil saying that frog is trying to jump to a specific point.
Exactly. Exactly. So it's nothing but so if you basically try to see this video again and again, so you will understand that the frog is trying to jump at a particular point, okay, in the air and then land, right? So this is what this frog is trying to do, right? You can see this, right? So you can see from here, this frog is trying to jump to a particular point and then land, right? And the reason because the analysis revealed that the change in the rotation speed of these tiny frogs were lowest among the group of amphibians. And apart from that, it basically revealed that uh, when the frog is in air, it basically takes time to land. Why it takes time? So that it can land smoothly. So that particular thing is decided in the air itself, and how like this frog goes, right? And its rotation speed. So this particular model was basically, you can see here, these were basically designed in MATLAB, and it was basically judged, or what I can say, analyzed using MATLAB again. Okay, so this is how the result came into the picture. Now, I want to show you one very interesting video again. You might think it's an interesting thing. So just see this video. You will, and then we will see. Right. So I guess everyone was able to see the video. Can anyone tell me what I am trying to show by this video? What's the interesting thing you saw in the video? Can anyone tell in the chats? What's the most interesting thing you saw in this video? Robot hands, right? So it's nothing but uh, this particular uh, this particular hand you are trying to see is basically a robot hand, right? Uh, so how did they do this? So they basically developed this particular tool or robotic hand. You can see here in Georgia Tech Center for Music Technology, using MATLAB and Simulink again. It was developed using the model-based design, right? So you can hear from him itself. I'm playing the video.
Ayush, Pradnya
Yeah,
here. We don't have the audio for this video somehow. Have you shared it with the audio?
yeah, I have shared this with the audio.
Yeah, could you just please check it once?
Sure.
Thanks.
Thank you. Uh, is the audio still not there?
No issue.
Mm, no.
Okay. Not sure why it's not there. So it's basically the interview of that person, and he basically tries to tell that uh, how with this help, how with this robotic arm, his performance has basically improved. Instead of doing it manually or with human hands, his performance has basically improved using this robotic hands, right? And it was again developed using uh, as I said, model-based design and Simulink, right? So this is one more user story just to motivate you where MATLAB and Simulink comes into the picture. Now, one very famous user story which I am sharing next is uh, Tesla, right? Everyone knows Tesla. I think if you are little bit on the social media, then you must be aware of Tesla, right? So, is Tesla MathWorks customer? Yes, definitely yes. Tesla is every automobile company, most of them you can think of are MathWorks customers, and Tesla also used MathWorks and MathWorks products to design their products, right? So they basically use MATLAB models where like in their cars, right? So this is one more interesting user story to get you motivated. You can find the links for all these user stories in your in this presentation, right? So next, uh, what industries uses MATLAB and Simulink? So aerospace uses MATLAB and Simulink, automotive, biological science, biotech, software industries, semiconductor industries, any industry you can think of is using MATLAB and Simulink. So are you guys aware of the recent ISRO launch, which happened recently, very recently? Are you guys aware of that? Uh, what was that? Can anyone tell me in the chat? What was the recent ISRO launch which happened? It was very famous. News was all around. Can anyone tell me in the chats what was that?
Chandrayaan 3.
Chandrayaan 3, right? So do you know if you go back and see the Chandrayaan 3 video launch, you will be able to see little MATLAB logo running over there, right? In real time. So again, MATLAB and Simulink came into the picture for even that, right? Even ISRO is our customer, and for designing Chandrayaan 3, MATLAB and Simulink was used somewhere, right? So you can go back and check. There is little MATLAB logo running over the screens of the scientists when Chandrayaan 3 launch was happening, right? So this is the significance of using MATLAB and Simulink. Uh, where you can use in every other company you are working with, you can expect to use MATLAB and Simulink. So with this, engineers and scientists are basically changing the world. Right now, one more user story which is very famous. I have not added it over here, but how many of you uses two-wheelers? How many of you uses two-wheelers? Any responses in chat?
Not yet, Ayush.
Okay, so anyone don't use a two-wheeler here?
We
I
have
guess.
we have one. We have one. Yeah.
Okay, okay. So you guys use two-wheelers, right? Okay, so I think people are just being lazy for now because it's just after lunch. The session is just after lunch, but uh, just try to interact to make it fun. Okay. Uh, so if you guys use two-wheeler and you go back and check, right? There is a company called Ather, right? It's very famous in India nowadays. It's a startup basically, but it makes two-wheelers, right? Electric two-wheelers. So if you go back and check, you will be able to see that MATLAB and Simulink were again used to design uh, that Ather 2 electric vehicle, right? If you go back and check today, you will be able to see that. We can also share the user story in chats. You can just have a look at that. Pratik, can you put the link for that in the chats?
Yeah, Ayush, I'll do that.
Thank
Also, I think we should, like, before we go ahead, maybe we
you.
can
Yeah,
ask some responses on the
sure,
chat of, like, whether there are any users of MATLAB right now in the
sure,
forum, and if there are, what are they using it for? Just
exactly.
feel free, everybody, to, let us know what you use MATLAB for if you have used it before, or Simulink for that matter.
Uh, yes, ma'am. Hello.
Yeah,
I am PhD scholar from NIT Andhra Pradesh. I am using MATLAB Simulink for designing my converters.
nice. College lab experiments, research related to vibration, signal processing. Any other use cases? ESG research, power system analysis, lab experiments, card, score perspective of exams. Nice. Research project. research project to predictive modeling. Great. So I think we have a good amount of people who uses MATLAB and Simulink over there in the call, right? So, and even from the chat itself, you can see that how many different uh, use cases we are seeing, right? Someone is using it for like their energy system modeling, someone is using them for predictive modeling, someone is using them in automotive modeling, go-kart, right? Someone is using them for their some other experiments for power system, for signal processing, right? So you can see from the charts itself that uh, MATLAB can be used in diverse domains, not a single domain, right? For EEG classification, great. So I think we have good amount of people here who uses MATLAB and Simulink already, right? So great. Anyone wants to discuss anything till now before I move on to the next part? Okay, so I am moving to the next part then. Uh, cool. Okay, so next part is basically how can you get started, right? That is also a thing, right? How can you start with using MATLAB and Simulink? So yeah, so first thing first, you have to have a MathWorks account uh, to use MATLAB or Simulink, right? So you need to have MathWorks account. That is the first thing you need to have. The process is very simple. What you can do is I will show you the live demo of how you can create your MathWorks account. That's just a simple step. I hope my screen is visible. Okay, no, just give me a sec.
Yes, it was actually.
The presentation was visible. I will show you yeah, I hope it's visible. Yeah, it's visible. So what you have to do is if you go to mathworks.com, you will go over there. Uh, so I already have an account created at this page. I will go here. So you go at mathworks.com, right? And you will see something like this, right? So I think people are here from different regions. I am from India, so I'm going to select the India website. Whatever region you are from, you can select that particular website, right? Now, if you go over here, you will see it will ask you to sign into your MathWorks account. So if you don't have a account already, just click on create one and put your email address, put your location, uh, put whatever describes you, whether you are a student, whether you are engineer, right? Put that, click on create, then you will be asked to verify your email address. Once verified, you are done with creating the account. This is like just a 2 or 3 minute thing which you have to do to create MathWorks account. So I will encourage, if you want, you can create your account just now, right? Uh, you don't have to wait for like creating it later. If you're joining in from your laptop or phones, great. Just try to create the account now. If you face any issues, me and Pradnya are there in the call till end. You can ask us if you are facing any problems while creating account. Okay, and it's advisable that use your official email address while creating the account, because it might be very well possible when you're creating your account that your if you are a student, your institute might be under uh, student community-wide campus-wide lessons, right? And with campus-wide lessons, you get to access everything we have to offer in MATLAB and Simulink. Okay, so yeah. Uh, so with this, I will be moving ahead. Yeah. So if your MathWorks account is created, now next thing, how can I get started, right? So we have something called as MATLAB Academy. I will show you, and actually we will do the basics of MATLAB and Simulink using that particular MATLAB Academy, so that you can go back and complete those things for your understanding, right? So let's move to MATLAB Academy. I will just stop the screen sharing for a minute and we will move on to the MATLAB Academy. So just give me a sec. Yeah. Uh, okay. So I'm sharing my screen again. I hope my screen is visible. If it's not visible, just let me know. So what you have to do is you have to go to this link, matlabacademy.mathworks.com. Okay. If you go to this link, something like this will pop up. Okay, if you are signed in, uh, then you can see that there are lists of courses here, self-paced courses, right? Getting started. Then under that, MATLAB, Simulink, AI, machine learning, deep learning, physical modeling, math and optimization, image and signal processing, right? So we have a bunch of courses over here. So since we are dealing with MATLAB on-ramp, it's a 2-hour course, right? If you want to like dive deep into MATLAB, you can complete this MATLAB fundamental course. If you want to do MATLAB for a specific application, you can do it using this particular course. So we are just concerned with basics of MATLAB for now. So I will just start with this. Okay. So once you start this course, something like this will start. Okay. So I'm just showing you these. Okay. Yeah. So something like this will pop up. Okay. So actually the interesting thing is you can do these things hands-on, right? There is no like this thing that there is only theory and you have to read and remember things. There is actually this hands-on platform. Basically, MATLAB Online is integrated into our all the courses and you can do things hands-on, right? So first thing first, how can you create variable in MATLAB, right? That is the first thing which can come into your mind, right? So simple, whatever variable name I want to give, I will give that. And it's similar to any other language you might be using, or you might have used, or what you have to simply say that uh, say my variable name is a, right? So it says that create a variable named a with value -2. So I have to simply do this, right? Okay, so if I run this, you can see that it has run, right? Now, one interesting thing I want to show you in the next example. Okay, now it's basically saying what you have to do is using these two values. Okay, so there is a concept of workspace. If you say see right in MATLAB and Simulink both. So in workspace, whatever variables you create over here in MATLAB, they are saved in workspace, right? And you can basically see whatever variables you have created till now, right? So for example, I have created small a, its value is 8. You can see over here, you can see its size, you can see its class, whatever variable, other variable. So capital A, its value is over here, you can see its size over here, right? Now if I want to use these variables, can I do that? Yes, you can do that simply by stating their name, right? And this is how you can use that, right? Can any can anyone tell what's the mistake? The variable name was not correct. It's basically saying to give a, I have given mean a. Okay. Otherwise, there is no issues logically, right? So this is how you create variables in MATLAB, right? Uh, Next is how you can save and load variables. Okay, how can you do that? So uh, you can do that in a file also, or yeah, So what you have to do for that is you have to simply state save and you have to give your file name and your variable will be saved in that particular file. Okay. You can empty your workspace at any point of time using clear command. Okay, let me show you. So clear command will basically, so you can see the workspace is empty now, right? Because clear command basically clears your workspace. Okay. Next, some things is vector and matrices. So how can you create uh, vectors and matrices, right? After all, what's MATLAB? It's basically matrix laboratory, right? So everything you do in MATLAB is nothing but matrices, right? So you can guess from the name itself. So it's saying that create a variable name x equal to 4, you create that, then uh, how do you create an array? So in the next task, we will see that. Yeah. So you move on to the next task. So how do you create a array, right? So you simply say the name of the array. You use square brackets. You give out the elements in those square brackets with space, and it will basically create an array for you. Okay. So similar to this, you can just simply complete this course. The whole point of me showing you these things is basically you can complete this particular thing, MATLAB on-ramp, and it's free for you, even if you don't have access to like campus-wide license or you don't have uh, any other licenses. You can just simply go on MATLAB Academy after signing up on MathWorks, and you can simply complete this course. And after completing this course, you basically get a certificate of completion. Okay, so you get a some yeah. So I'm exiting the course and I will show you. You can simply get a certificate also, right? So you can see that I've got this certificate. And I can share it on different platforms, right? Uh, which is basically verified by MathWorks team, right? So you can boast about your certificates also at the same time you get knowledge of doing things. So it's your task now. What you will do is before coming to session tomorrow, you will go to MATLAB Academy. You will complete this MathWorks MATLAB basic course. Okay, MATLAB on ramp. Okay, so to get familiar with MATLAB. Anyone have any doubt in this particular thing? Anyone and have any doubt?
So, Ayush, yeah, so that's exactly what I was coming to. Nabil has just said if someone has a basic knowledge already, then what do we do? So,
Exactly.
so everybody, so what is the requirement here is that tomorrow we are going to, today we are going to start off with a little bit of ML workflows, if possible, if time permits. And then tomorrow is going to be a dedicated session in which we are going to look at how you can do advanced ML and AI, or even for that matter, DL, deep learning workflows with MATLAB. And if you already have the basic knowledge of MATLAB, that's great. But I'm sure that there would be a section already of the audience which might not have some knowledge that's needed, right, for the session tomorrow. So this is specifically for those who are probably beginners when it comes to MATLAB, right? So feel free to go and explore the online course today if you haven't yet. But if you have already started using it, you have done the course, or if you've used MATLAB for any of your project work or for learning or for teaching for that matter, if there are educators in the forum, then basically, you are prepped for tomorrow's session.
Apart
So
from that, yeah, sorry, Pradnya. Yeah, you
yeah,
can
no,
continue.
so it would be nice to know in chat if there are people who have already done the MATLAB on-ramp, or I mean, what is your know-how, right? Many people said that they have used MATLAB for various project related works, and specifically with respect to courses, but because there are many participants here. I think it's a nice point to here stop and see if there are people who have completed the MATLAB on-ramp. At least if you have completed MATLAB on-ramp, please go ahead and type yes on the chat so that we have an idea.
Great.
Yeah, so Nabil, it is not necessary to learn this course from the academy. That's not what we are trying to say. This is just a starting point that we generally give to people who haven't kind of, explored. So if you've already used MATLAB for anything else and you're well versed with the basic concepts, that should be good. There's no need to start off again with on-ramp on academy. Okay, so we'll just probably keep monitoring the chat. If there are any
Sure.
more people who are already aware about MATLAB or have done on-ramp for MATLAB, please feel free to type it out.
And those who are saying that they have already done the basics, so you don't have to worry for that. So we also have advanced courses also, right? So you can see that you can go deep into the things now, right? Since you have this basic knowledge, so you can go and complete MATLAB fundamentals, right? And not just that, you can basically do data processing and visualization course also, right? And if you are looking for some specific domain related thing, you can go into that particular domain. So for example, say I'm looking at image and signal processing, right? So you can go and do that, right? uh, it's not for session, but in for your general knowledge also, for your knowledge also, right? So you can go and complete these things also, uh, for your knowledge, right? For your knowledge building. And most of the things are available to you even if you don't have any licenses. And the best thing about these courses that I like is you can share the certificates on LinkedIn or any other platform you want, right? So it's also a great thing, right? It gives you that sense of achievement, right? So that is there. So with this, let me move forward. So similar to MATLAB on-ramp, we have Simulink on-ramp also, right? So you can have an overview, then uh, what Simulink is all about. Let's move to this, right? Simulink graphical environment, right? And the great part is we have Simulink and MATLAB online, so you don't have to download if like say your system don't have enough memory or for any other reasons, so you don't actually have to download things. You can just go ahead in the online manner and you can complete things, right? You can see I didn't download anything. Simulink is opened in my online uh, space, right? So Simulink online, right? So
So
Simulink,
Ayush,
yeah.
I think, yeah, we did get a few responses as far as the on-ramp is concerned, but they were handful. So what I'm
Mm,
assuming here is that, if a majority has not looked at the basics of MATLAB, then I think they should go ahead and try this course today. And
right,
it would just help you. It's not that you're not going to understand the workflows for tomorrow if you don't do it, but it's just something that would make things easier tomorrow when we try to do some advanced workflows with you as well.
exactly. So it's not necessary to complete any on-ramp, as Pradnya said. It's just for your knowledge, right? To give you that perspective of how things are done in MATLAB and Simulink, right? So you can go ahead and complete these on-ramps. It's freely available to you on MATLAB Academy site. You can just complete them, right? So with this, do you have any other doubts related to what we have covered till now? If not, what I can do is I can start with the next part of the session, which was basically ML, AI, and DL part. So anyone has any doubts? So someone asked that can we cover about optimization tools and GUI? It will not be possible to cover that in the session, but what you can do again is we have like specific on-ramps for the optimization part. You can just go and have a look at them and maybe do them. They are very short, like 1 or 2 hour thing. So you can just get started with that. And if you face any problem, you can just mail us over our emails, right? Okay, so I'm moving on to the next part now. Which is machine learning and deep learning using MATLAB. Cool. Yeah. I hope my screen is visible. Pradna or Rishi, can you confirm if my
Yes,
screen is visible?
yes, it is. It is. Ayush, I was just thinking, should we break for like at least 5 to 7 minutes just to kind of make sure that, people are fresh when it comes to the start of the new topic?
Sure,
I mean,
sure.
it
Yeah.
completely depends on you. How do you want to do it? So take a call
It
accordingly.
it depends on our audience. Guys, do you want to take a break? Even if there are 4 or 5 responses, we can take a 5 minute break. If you want, we can start at like say 4:55 or like 5, whatever you feel comfortable. So, guys, do you need a 5 minute break? If yes, just type in. Okay. I received one yes privately. Yes. Okay. Cool. So I think it will be good if we take a 5 minute break. So cool. So what we will do is we will start again at 4:55 freshly with our new topic, which is basically machine learning and deep learning using MATLAB. Okay. So you guys can just quickly grab a coffee or whatever you want to do. Just quickly grab fresh air maybe and come back. You don't have to leave this call. We are here, and those who don't want a break, you can ask questions. You want to discuss anything in the chat, you can go ahead and discuss. Are there any, I just want to confirm, are there any faculties or researchers in the call, especially faculties from any particular institute? Are there any faculties in the call? Great. Cool. You want to ask anything? We will resume at 4:55. Okay, people are here from Pakistan also. That's great to see. Someone was from Malaysia. I think people are joining in from like different parts of the world, so it's great to see. Anyone wants to discuss anything till we resume? So, yeah, I received a query that can we conduct a session on specific toolboxes in MATLAB and Simulink other time. So the next part of the session which we are going to do are basically based on the specific toolboxes in MATLAB and Simulink, right? It's basically related to the machine learning toolbox or the deep learning toolbox we have, right? In MATLAB and Simulink. So I think it answers your question, Shanila.
Also, Ayush, I think you should take time to let the academicians and educators who might be on the call right now to tell them a little bit about our team, like the customer success team overall in worldwide education team of MATLAB and how we help educators. Maybe you just can give them an intro while they are here.
Actually, that's there in the slide, Pradnya, like next
Okay,
slide.
sure, sure. Okay, makes sense.
Yeah. So there is nothing missing in academic license, Ritesh. Uh, the beauty of having an campus-wide license or an academic license is that most of the things are there in the not most, all of the things are there in the academic license. So when you are using that, so all of our toolboxes, everything you can use with an campus-wide license. And yeah, so it's not different from having a business or a corporate license. It's just that it's specific for the academic institutes. So you can actually make full use of license if your institute is on campus-wide license. So it's a great thing if your institute is on a campus-wide license. So someone asked that discuss some outcome of MATLAB and Simulink, right? So I think we already discussed that in the first part of the presentation, right, Adil? So the outcomes were clear, right? So you see like different engineering systems, right? You see maybe a automobile, you see maybe a drone, you may see maybe a two-wheeler, right? Or you see maybe a phone which is running in your hand. You see maybe a rocket, right? So these are basically the outcomes of MATLAB and Simulink only, right? So MATLAB and Simulink are basically being used in like different engineering systems you can think of across the world. Whether it's finance, whether it's any domain you can think of, MATLAB and Simulink is being used there. Okay, so I'm
And
coming back to the
also,
yeah,
Ayush, sorry
yeah,
to interject again.
yeah.
So because we have a lot of queries related to the toolboxes and, specifically about the license and in general about MATLAB and Simulink maybe, and I'm sure people might be having questions regarding their specific project work that they're doing with MATLAB and Simulink, right?
Mm,
I think one advantage of MATLAB and Simulink as a software is that we have a very rich documentation resource, unlike most other softwares today that could be used for simulation. So, if you're in doubt about anything for that matter, I think the first point to start out should be the MATLAB documentation, right? So, if you're using the desktop version of MATLAB or if you're on MATLAB online, just please go to the documentation tab and type out a few words out of your query, and I'm sure you're going to get a lot of resources which might be examples. They might be just pages that describe that particular example or concept, or there would be tech talk series that experts from MATLAB have put together for you, right? So there are videos, there are examples, and there are also examples that have been contributed by the community, like, students and professors such as you, which go on File Exchange. So a lot of stuff there when it comes to the documentation page here, right? So if you just type on top, like on the page that Ayush is sharing, it says search help center right on top. And if you type, say, optimization here or say power electronics, anything for that matter, you will get several resources. And on if you see on your left hand side pane, there are specific, related applications,
domains.
disciplines,
Yeah.
etc. And on top ribbon, you can see that there is documentation resources, almost like 6,000 plus resources only for this topic. Plus, there are examples. So there are working examples that you can directly use in MATLAB, and there are codes that you can kind of implement. There are functions, there are blocks, there are apps, there are videos, and then there are specific answers which might be, maybe related to your questions. And the best part is the last one is on File Exchange. That means a lot of users such as you have actually contributed to putting together these resources, and you can just download them and use them for your work. So please feel free to start out using the documentation of MATLAB. It is very rich and very well maintained and updated. Yeah.
Yeah, thank you, Pradnya. So yeah, definitely you can go on our website and you can just check out things, and you will be amazed to see that how much documentation, how much things which are already there. So I think someone just asked, how can I start with a particular system? Maybe I think it was a power electronics thing. So you can just simply go here and type that, say, power electronics, uh, and you will be amazed to see that how many resources we already have for that particular thing. There is one more very interesting thing which is called as community. You can go here. You see that we basically have community which is MATLAB answers. So you can just go and do that. And apart from that, we have a very interesting thing. So I can maybe just show you that. It will be very interesting to show you this. So everyone nowadays is using Chat GPT, right? So we have our own AI chat playground, which is there now. I think it will be released soon for common use. It's since I am part of MathWorks, so I have access to this, but I can show you. So for example, you want to create a 3D bar graph of data uh, from, say, some magic function. So you can simply write it here, and the beauty of it is that you can run it in real time, right? You don't have to like copy paste and then go to your MATLAB window and then do this. So you can do this it in real time, right? So it's a very interesting thing, right? To play around with, right? This particular AI chat playground which we have developed. So yeah, I think we can continue with our session with this. So cool. I will just continue with the session now. Just give me a sec. Please just continue pouring in your questions in the chat. Pradna will take care of that, and we will also look at them at the end. Okay. So you can just put in your questions, and we will take care of your questions. Okay. Okay. So the next part of the presentation comes now, which is basically machine learning and deep learning using MATLAB, right? It's a buzzword now, right? Everyone you see, like, it's a very interesting thing. Uh, so it's a very real story. So I was at my like visa interview a day before yesterday, and so people were there for their master's application, right? Who were going to study abroad for their masters, right? So when you go for a visa interview, they ask you like what particular course you are going to study for, right? In the like particular country you are going to, right? It was basically for the US. So people over there, so at least I think I heard around 15-20 interviews, almost 15-20 out of them, like out of 20 I can say 18 were for like AI, right? So 18 were there for AI. So it's a buzzword you use, right? So you see, right? So machine learning and deep learning is everywhere now, right? What is this, right? What is ML? What is AI? What is DL, right? I think I used to struggle between understanding the difference between these, right? I used to think everything is AI, right? But what again is AI, right? So we will answer all these questions today, right? And one key takeaway which you definitely will have is that uh, you will be clear with the difference between these three things: machine learning, AI, and deep learning. I am that sure, right? So you will be clear with the difference between these three things till the end of the session today. Okay, so the plan today for today is that I will start with the introduction to AI, where I will introduce AI, ML, DL. I'll give out some specific examples. I will give out some specific things, and then we will done a real world example of predicting a fuel economy using regression. So what is regression, right? uh, we will see that in the session, and then we will conclude today's session with this. topics, right? And then when we come back tomorrow, we will be doing clustering and classification. Then we will do some deep learning examples, and we will cover some deep learning basics through that examples. I hope everyone is clear with agenda. So the learning outcomes for this session, you can say, is you will have a fundamental knowledge of AI. You can design and train AI models with interactive tools in MATLAB. You can automatically generate code for the reuse of that. So the prerequisite is to understand this thing better. You can have a MathWorks account, you can have MATLAB installed, or you can access MATLAB online. Uh, and you should have done like basic MATLAB on ramp. So it will be good if it's done. If it's not done, that's also great. You don't have to worry. We will take uh, care of that also. Now, I'm just taking a minute to introduce our team. What does our team do? So we are basically customer success engineers, and as the name suggests, we help you succeed, right? So who are these customers, right? Uh, is it only those industry which I talked about in my presentation? No. So MathWorks basically uh, like cater to education sector a lot, right? We value education a lot. For most of the companies, it might just be a CSR activity, but at MathWorks, we take education very seriously, and we have a dedicated team of 15 or 14 people in India, which basically takes care of this education sector. So what does our team do? We basically connect with faculty, we connect with researchers, we connect with students to support them in their STEM initiatives, to support them in their curriculum, to support them in their research, to support them in their day-to-day activities using MATLAB and Simulink, and we help them integrate these systems into their curriculum, into their day-to-day workflows. So this is what our team does. So if there are any professors, if there are any researchers, uh, if you want some specific help in your curriculum building, if you want help in your specific research, you are stuck somewhere with using MATLAB or Simulink, you want to know how you can integrate MATLAB and Simulink into your research or your work, you can just reach out to our team and we will help you with it. Pratna, do you want to add anything?
No, Ayush, I think you summarized it quite well. I just would probably add one line that, I think one of the biggest strengths that MathWorks has today is its customer success engineering team, or specifically dedicated people to help out, educators and students and researchers around the world. So we are basically application engineers, but for our education customers, right? So please feel free to write to us if you have queries regarding your teaching, specifically if they are educators. If you want to include computational design thinking tools such as MATLAB or Simulink in your courses that are already ongoing, right? And you want to make your teaching more interactive, and you do not know where to start, right? Or if you have already used MATLAB, but then you do not see students making the best use out of it, and you want to make it, slightly more better in terms of our capabilities, tool capabilities, then we are the team you should write to. So we will be sharing our email addresses post the session, and Rishi will have it as part of the workshop follow-up email as well, probably. So make use of this dedicated team, I would say. And we are happy at that. That's our daily work, right? We are happy to kind of support students and educators around the world, specifically to include computational design thinking. Um, yeah, that's all, Ayush. I think nothing more from my side specifically. Yeah.
Thank you, Pratna. Yeah. So I think with this we can move ahead with our session. So how has deep learning evolved in MATLAB, right? So earlier in 2016, we only used to have some CNNs, only used to have some pre-trained models, and we used to have a cafe importer. Then in 2017, we introduced some algorithms. We introduced the feature of code generation. We introduced image labeler app. We introduced interoperability. In 2018, we introduced some examples, we introduced some more algorithms, right? Then we introduced what we call D&D, Deep Network Designer, which we will be using in our examples also. Probably tomorrow you see how Deep Network Designer works, and then we add ONNX support. Then in 2019 we added some algorithms, RL algorithms, uh, and some more DL algorithms. Then we added some more examples. Then explainable AI came into the picture, and then there was one more app which was introduced, Signal Labeler app. Then in 2021, I am just skipping 2020, 2021. We have now over 250 plus examples. We have RL Designer. We have model-based design feature in like Simulink now, where you can have your neural network in Simulink. Then we have some more other algorithms, and we have introduced TensorFlow interoperability with MATLAB and Simulink. So yeah, this is how deep learning has evolved in MATLAB. Now, how would you like to rate your AI knowledge? Are you an AI beginner? Are you an advanced user? Or are you an expert? It would be great if we can take a minute to gauge like what is our audience level of expertise in AI. So you can just put in chat uh, as A, B, C. If you are a beginner, A. If you are a user, advanced user, B. And if you are an expert, you can put in C.
We have a lot of A's coming in, Ayush.
Cool. So I can just guess from here that most of you are AI beginner, right? So my question to everyone is, what is AI? What is AI? So Rishi, can you unmute? Like, can you give the option of unmuting for everyone for like next 5 minutes? And I will like to listen what people think of AI.
It's done.
Yeah, so guys, you can unmute now, and if like just for answering this try to unmute and try to tell us like what do you think of AI?
This is Nabil from Pakistan.
Yeah,
As far as the basic information of AI is concerned, the AI is about training some machine and so that it can work intelligently
okay,
for some
so
task.
nice. So Adil thinks it's basically training a machine to work intelligently. Okay, any other answers we have
It's an
for what is AI?
it's an intelligent device which can also replace human as well.
Device which intelligent device which can replace human. Okay, so keywords I'm taking from Adil is uh, training machine uh, to do intelligent work, and from the next person, uh, intelligent tool or device uh, which can replace humans. Okay, any other answers for what is AI? Don't answer artificial intelligence. Okay,
Is the device that can take its own decision depending on
device
the
that can take its own decision. Okay, any other answers you would like to give before I help to make decision based on historical input? Okay, great. Any other answers? Using computers to analyze. Okay, making machines that can think like humans. Okay. Hmm. So, okay, we received a lot of answers, right? So, what is common in all of these answers? Can anyone tell me quickly? What is common in all of these answers, whatever we are receiving? What
Smart
do you
work.
think is smart work? Okay. Other thing? So see, the presenters are very clever. Until I don't hear
Yes.
the specific word, I will keep asking for more. Okay. So what do you think is the common things out of this
A device is doing the human work virtually or
human
parallelly.
work? Okay. Some more answers. Interprets output. Okay. What is common in all of the answers? Okay, so I am covering this now. So any technique, intelligence is nothing but any technique, right? Which can enable a machine, any machine, to mimic human intelligence, right? That can be called as artificial intelligence, right? Name itself suggests that artificial intelligence. Artificial means it's not human, right? It's artificial. It's human created, right? It's related to a machine, right? Machine intelligence, right? So any machine which is able to mimic human intelligence, I can say it's AI, right? So or any technique, whatever it can be. So uh, AI is basically mimicking human intelligence. So I think this was what I wanted to hear from you, right? So uh, it's basically an umbrella term. AI is basically an umbrella term which covers machine learning and deep learning, right? So what we are saying here, any technique, right? Now we need some technique to mimic this human intelligence we are saying, right? To take decisions, to do tasks, right? So we need this human intelligence. How can we do that? So machine learning and deep learning comes there into the picture. Machine learning and deep learning is basically the way are, and these are basically the techniques through which you can enable the machine to uh, perform AI, right? To have that artificial intelligence, you can use machine learning and deep learning. That's why machine learning and deep learning are uh, under artificial intelligence umbrella. Now, what is machine learning? What is deep learning? What is machine learning? So what does the name suggest? Machine learning, right? The learning of machine, right? So any methods which basically uh, let your machine learn from data, uh, learn from tasks, right? Without you programming like manually that, okay, do this, do that, right? Machine learning on itself is called as machine learning from given data is basically machine learning, right? So the name itself is pretty explanatory, right? Now, deep learning, what is deep learning, right? Can anyone tell what is deep learning? Deep
Deep
learning,
learning is
yeah.
basically the involvement of the learning of the machine or creating an artificial brain inside the machine. This is deep learning.
Okay. Yeah, exactly. So creating an artificial brain, this is an interesting term, right? Creating an artificial brain inside machine, right? What does creating brain mean? That you want to tell explicitly like very less things and you want machine to do its own work on itself, right? So what happens in machine learning is you have to explicitly tell that these are the features of my data, learn from these features, right? But in deep learning, you don't have to do this thing. Machine becomes more intelligent. Machine tries to mimic human brain behavior itself, and it tries to learn directly from data instead of you explicitly telling that these are the features of data. So deep learning is nothing but it comes from human brain, right? So it has networks. So you might have heard of a term neural network, right? So deep learning is implemented using neural networks, and neural networks is nothing but how neurons are connected inside your brain, how they transfer information, how they learn from information, right? Similar thing we try to replicate inside our neural network inside deep learning. So this is what AI, machine learning, and deep learning individually mean. We will look at more detailed description later in the presentation. I hope everyone has some basic understanding of what AI, what machine learning, and what deep learning is from these slides. So I'm moving forward. Machine learning is everywhere, right? You can't be can't skip machine learning now, right? You can see machine learning in automotive industry, right? Uh, for example, you can learn about tire wear and tear, right? From machine learning. You have it in manufacturing industry, right? You have in communication industry, right? Uh, Customer churn prediction you can make using ML and AI. There are other things in telecom industry which you can do using ML AI. So one thing which is coming into my mind apart from that is, for example, you want to put in like a signal uh, strengthener at a particular area as a telecom industry, right? How will you judge whether to put where to put that, right? So you can use ML and AI there that this particular area has this much users, right? You can predict the usage and like signal strength and everything, right? And using all those things, you can say that whether this particular area needs that or not, right? In energy and finance, in finance, you can see that we can predict stock prices, we can uh, do risk analysis, right? So in uh, different industries, there are different use cases of uh, machine learning and deep learning, right? So you can see over here different industry use cases. So you can't actually skip from machine learning now, right? Because it's everywhere. Is my screen sharing stopped? Yeah, I think so. For some reason, it stopped itself. I'm sharing again. No worries. Okay, right. So moving on to the next part. Right. So as I said, we will now dive deep into the machine learning, right? What is machine learning, right? What do you think? Ability to learn from data without explicitly programmed, right? This is what we understood. So where or how you can apply it, right? Where you can apply it. You can apply machine learning in speech recognition. You can apply it in object recognition. You want to monitor an engine health. You want to forecast energy load. You want to forecast weather. You want to make prediction on stock market. Whatever use case you have, you can easily, out of these use cases, you can easily apply machine learning over there, right? Um, right. So basically solution is too complex for example in these cases when you want to do speech recognition, right? Or you want to do object recognition, right? So the solution is sometimes too complex, right? You can't just simply give out some equations and you can tell machine that learn from this. So you need some complex relationships which are not directly linear, like you are not directly mapping something to something, right? You need some non-linear relationships over in these cases. uh, in case of forecasting, right? You want to make some particular prediction, you need more and more data, right? You want to learn, so for analytics case, you need large data sets, right? So you need a scalable solution in that case. So uh, different applications require different things, right? Uh, in machine learning. Now, what is machine learning, right? I said, so it's basically what I said, it's basically to machines ability to learn from the data, right? Now, how it basically learns from data, any idea? Anyone wants to write in chat? How does it learn from data? Do I just simply say that, okay, this is my data, learn from it? Or how does it learn? What do I tell to machine uh, so that I can say that, okay, the machine is learning? What do we do? What do you guys think? Okay, analyze the output for that input. Okay. Okay, let's discuss this. I have stopped sharing. I want to read the responses. So someone is saying learning from its own tasks and failure. Someone is saying feed data, analyze the output. How do we enable machine to learn? How do we enable machine learning? That is my question, right? Okay, let's take a very quick example, okay, from real world. So say I want to teach a small kid, right? There is a small kid, and I want to teach that particular kid about shapes, right? Uh, maybe how does a triangle look like? How does a square look like? How does a circle look like? How does a rectangle look like? How do I teach that kid about shapes? How do I teach kids about shapes? You show him shapes and you label them, right? Visual representation by showing different shapes of the object. Exactly. So what can I conclude from this? From the yeah, someone is trying to speak. I think Veenu, you want to speak something?
Yes, I would just would like to say you have to pass your data to the machine, prepared data,
Okay,
so that the machine can
okay,
read those instructions and give an
okay,
out.
okay. But I simply pass the data and I say that learn from it. Will the machine be able to learn from it? No. Okay. I simply give shapes. Say I want, we are taking this same example again. I want to teach the kid about the shape, right? Do I just simply show the shapes and I say, okay, these are the shapes and learn from this, right? No. What do I do? What do I basically do is I tell this particular kid that, okay, if you are seeing a shape, you have some features in a particular shape, right? So for example, triangle has three sides, right? Square has four sides. Now, how do you differentiate between a square and a rhombus? Uh, how do you differentiate? You tell them about angle, right? You tell them about diagonals, right? Or you, let's say you want to differentiate between a square and a rectangle. You say that in square all the sides are equal. In rectangle, uh, opposite sides are equal, right? So you tell them about the features of that particular data you want the student or the kid to learn about, right? In case of shapes, we tell them about sides, number of sides, we tell them about diagonals, we tell them about angles, right? So these are basically the features of that particular shapes, right? So similar to this particular example, in machine case also, we have to tell machine about the features of the data so that it can learn from that data, right? So for example, I want to do number recognition, right? So I have to tell if you are, if so say I'm giving machine some different data of numbers. I want to predict which number will it be, right? So for example, I'm giving 9. So I have to tell machine how does a 9 or what features does 9 have, right? So for example, 9 is something like this, right? So I will say that it has circular shape, right? These are basically the features of 9. Or say I want to tell machine that how does 10 look like, right? So I will have to tell the features of 10 to a machine, right? So you have to tell features of the particular data so that machine can learn from that particular data. And uh, telling features, defining your features is nothing but machine learning. That's what this complete thing is, nothing but machine learning. You basically tell your machine about the features of the data. You let machine learn with the help of that features from the data, and then it's able to predict for your new input, whatever you are giving. So this complete thing is machine learning. Is everyone now clear with what machine learning is? Is everyone clear with what machine learning is? Anyone here with who is not clear with machine learning? If you are not clear, that's completely okay. You can just let us know and we will try to clear it. Okay. So I am moving ahead now. Okay. In the session. I hope my screen is visible. If it's not, just let me know. I'm moving ahead. So I just discussed in detail what machine learning is, and I hope everyone is clear with machine learning now. Okay. So when it comes to machine learning, so based on data, we can have different type of data, right? How different type, right? So two types of data we generally say we can have two types of data when it comes to machine learning. What two types of data? One type where we have input output labeling, right? We can map the data, right? And one data which is kind of one thing only, we only have input, we don't have any kind of mapping, right? So when we talk about data, we basically try to classify machine learning based on the data on two types: supervised learning and unsupervised learning. What is supervised learning? So in supervised learning, what we basically try to do is we basically try to develop the model based on both input and output data. We have this input output mapping in the data, and using that we try to basically uh, make the machine learn about that particular data and develop the model. So for example, can anyone give me an example of this input output labeling example? Can anyone tell me? Okay, so I am going to take the similar example we did. So for example, the shape example, right? Level of sugars, medical field, level of sugars. Okay. Can you explain this example? You can, I think, unmute and explain if you want. Environment. Yes, I think someone asked, is RL a type of machine learning? Yes, RL is also a type of machine learning, but we are not going to cover that because it's advanced topic which is not intended for this session. Okay, so RL is definitely a type of machine learning, but you don't have to worry for that. Just try to focus on what supervised and unsupervised learning is for now. Okay, so yeah, I think we have some answers in the chat. So I'm taking an example of what we did just now, input and output data. So for shapes, right? So I can simply have a data of shapes where let's say input is number of sides, output is the shape, okay? And let's say number of sides is 3. I can simply say it's a triangle. Number of sides is 4. I can say it's what? Let's say square, okay? Number of sides is 5. Pentagon. Number of sides is 6. Hexagon, right? So similar to this, number of sides 0, nothing. Number of sides 1, it's a line, right? So this kind of input output mapping I can have, right? Or let's say you want to predict uh, the temperature. Okay, we want to make a model for predicting temperature, right? So I can have two types of input. Let's say I'm predicting temperature based on humidity, right? So one in one column I have input as humidity, and in the other column I have output as what it suggests about the temperature. So if it's too humid, I can say it's hot. If it's less humid, I can say it's a little cold. If it's moderately humid, I can say it's let's say if it's too humid, it's raining. If it's moderately humid, I can say it's hot. If it's less humid, I can say it's cold, right? Or it's a pleasant weather, right? So these kind of input output mappings I can have, and based on this, I can develop a model. Okay. And in unsupervised learning, I will have just one type of data and I will have to predict based on that. So let's say you have data, let's say, what can I say? you have a deck of 52 cards, right? So you have those 52 cards and you want to predict which type of card. So let's say you pick a card from deck, what card will it be, right? You want to predict that. You want to make a model for that. So unsupervised learning can come into the picture there, that you just have one input, that you have cards. Now, how do you basically develop or make that particular algorithm of predicting a card, right? So I hope everyone is clear that we have two types of machine learning based on the data we have, supervised learning and unsupervised learning. Supervised learning is basically when you have input-output mapping in data. Unsupervised learning is when you have only one type, which is input data only. Now, in supervised learning, we have different algorithms uh, which can cater to supervised learning. So first is regression and second is classification. What is regression, right? Can anyone tell what is regression? Okay, so I'm covering this since we might fall short on time. So uh, regression is nothing but uh, what training your data, linear data, okay, training your input output data using machine learning and predicting based on that. Okay, so you basically try to, and now in the input output mapping also you can have two types of data, right? It can be a continuous data, it can be a discrete data, right? So in case of continuous data we use regression. Okay, you want to continuously you have like continuously mapping of input output mapping, you want to predict using that. So in that case regression comes into the picture, and classification comes into the picture when you have this discrete data, right? So you can classify your data, right? Based on that, you give out labels to your data in case of classification, right? So for example, you want to train a classifier to classify human activity from sensor data. So say in input you have like so you have this mobile phone, right? So you are collecting data from this mobile phone, let's say accelerometer data, gyroscope data, right? And using that input data, you want to predict what the person is doing, right? Whether he is standing, whether he is walking, whether he is climbing, whether he is uh, like sleeping, right? You want to predict that. So you can do it using classification. What you have to do, you have to classify uh, for input output mapping. So for example, I have some readings, I will classify that this particular readings falls into the category of sleeping, let's say. These particular readings falls into the category of uh, walking, right? So this is how you classify. Next, in unsupervised learning, we have clustering, right? So let's again take the data of or the example of the cards we just did, 52 cards, right? Now, uh, is there a particular way I can segregate my cards? No. So I'm just stopping for now, just for the explanation purpose. So actually, how or what you want to predict also depends on uh, so what you want to predict basically tells you what you want to like how you want your model to be developed, right? So for example, in case of cards, right, whether I want to predict the number of the card or whether I want to predict the color of the card, whether I want to predict the type of the card, that will basically tell me the model I want to develop, right? So for example, if I want to uh, predict the color of the card, right? So it will basically tell me the type of model I or not type is not the correct word. It will basically tell me what I need from my model, right? So basically what I need, I want to differentiate the color, right? I have in cards. So for example, in 52 cards case, I will have two colors, red and black, right? So I can differentiate my cards in two sets, 26 in red, 26 in black. Similar to this, if I want to predict, like let's say into the set, whether it's a tree, whether it's a spade, whether it's a heart, whether it's a diamond, right? You want to predict that particular thing. So how you will basically cluster your data, right? How will your what I would say, group your data, right? So you will basically group your data or cluster your data into 4 groups now, right? Whatever input data you are giving. So uh, whatever you want to predict, right? That basically tells you uh, what you need from your model, right? So continuing to the slide now, I hope everyone is clear with clustering now, right? So for example, in this particular example, right? So for example, we want to tell, I want to tell uh, given data is for engine speed and vehicle speed, you have to identify, you have to put data in clusters, right? So using vehicle speed and engine speed, I can put my data into clusters. So for example, the vehicle speed when it's between 0 to 10, right? And engine speed is between uh, let's say 1000 to 3500. I can see most of my data is lying into the red region, right? The vehicle is in first gear. I want to predict the gear, so vehicle is in first gear. When the second gear is there, so my vehicle speed range is 10 to let's say it's going till 25 or 30, and my engine speed is going from 1000 to 3500. So this is how you basically classify or cluster. Classify is not the correct word here. This is how you group or cluster your data into different groups, and using that groups you define or you tell, you make the prediction. I hope everyone is clear with this now. Clustering. Is everyone clear with clustering? Pradnya, are we having any yeah, responses in chats?
Yes. Yes, we are having a few responses.
I hope everyone is clear with all these things, regression, classification, and clustering. And now you should be able to define the difference between different types of machine learning, uh, how it's based on, like different types of learning, what it's based on. Then in that particular learnings, how are regression and classification different? What is regression? What is classification? What is clustering? I hope you can answer all these questions now. And if not, you can just simply go back and watch the recording. Rishi will be providing the recording to you. The session is being recorded, so you record it, so you don't have to worry, even if it's not clear. So I'm moving ahead. So, um, so to perform these particular tasks or algorithms which we discussed, regression, classification, clustering, we have different models which are already there. For regression, we have support vector machine, we have naive bias, we have nearest neighbor techniques, right? For classification, we have linear regression, we have ensemble methods, we have decision trees. You will hear decision trees a lot for classification. For clustering, we have k-means clustering, we have Markov models, we have Gaussian models, right? But in all these things, one thing is common, right? Everyone is able to see that one thing is common in all of these things, which is neural network, right? So deep learning is uh, common in all of these things, right? So, and then there is again one more type of machine learning which we didn't discuss. I think someone mentioned it. There is reinforcement learning, but we are not covering that because it's an advanced topic. If you want to learn, we have an on-ramp for reinforcement learning also. You can just go ahead and check out reinforcement learning on it. So I hope everyone is clear with it. So deep learning is basically a subset of machine learning, and it can be applied for regression, it can be applied for classification, it can be applied for clustering, right? Okay. Now, uh, okay, I am clear with what is machine learning. I'm clear with what is deep learning, but what's the difference between machine learning or deep learning, right? That can be your next question, or I think that should be your next question, right? So the difference is very clear now, right? In case of machine learning, you require domain knowledge. The data can be less, but you have to explicitly tell your machine about the features of the data, and based on that features, your machine learns from the data, right? That is what machine learning is. But in case of deep learning, it's opposite. You don't have to explicitly tell your machine about the data, but again, at the same time, since you are not telling your machine about different things about the data, you need a lot of data so that machine can learn from that, right? Machine can make conclusion about different features from data, right? So you need a lot of data for deep learning. Domain expertise is not that much required in case of deep learning, right? So what do we see when we talk to different people in industry? The biggest challenge everyone faces is that where do I use machine learning? Where do I use deep learning? So this chart will basically give you a better idea when to use which technique, right? So at the high level, I can say deep learning needs tons of label data. You can see here, right? Needs tons of label data, and it has like higher computational requirement, you can see from this particular chart. Whereas in case of machine learning, you need less data, or you need less model complexity, but the domain knowledge which is required is very high, right? For example, why domain knowledge comes into the picture, or where does domain knowledge comes into the picture, right? So for example, I am working in a biomedical field. Say I am working in a biomedical field. I have images of human brain. I want to make prediction of age using human brain, a human age using human brain, right? I have pictures of like scans of human brains, right? In case of deep learning, things are simple, right? I can just simply give out the data to the machine, and it will learn from the data itself, and it will start making predictions. But in case of machine learning, I have to explicitly tell different features of brain, and then only machine will be able to learn, right? Different features of brain, and based on that features, what should be the outcome, I have to tell explicitly to the machine, right? So I need that domain expertise in case of machine learning, that how do I uh, tell about the features of the brain, right? So I will need that domain expertise there. So that's where domain expertise comes into the picture in case of machine learning, whereas it's not that much required in case of deep learning. So I hope everyone is clear. So basically, you need to consider how much time and expertise you can bring uh, for deciding what technique to use. And definitely dataset plays a very major role in deciding your technique which you are going to use. I hope now everyone is clear with this question also, that which technique you have to use where, right? Now, disregarding of the techniques, machine learning and deep learning can be applied to different types of data. Okay, and these different types of data can be images, these different types of data can be videos, signals, numeric, and it can be text data also. And all these like data can be converted to tabular form for easily working with that data using MATLAB. So you don't have to like worry about converting it into tables to work with the data, right? Actually, when you work with machine learning or deep learning, you will work with tables a lot. Okay, whether you are working with MATLAB or not, you have to work with tables if you are working with machine learning and deep learning. So MATLAB basically gives you an easy way of converting these data into tables. Okay, now whenever you are working in an AI workflow, okay, so there is a very basic workflow, I would say, which you have to follow for any AI technique you're using, whether it's a machine learning technique, whether it's a deep learning technique, right? So what's the model you have to follow? So the model or the workflow is simple. You have like 4 steps into the picture. First is data preparation, second is AI modeling, third is simulation and test, and fourth is deployment. What is data preparation? Data preparation is simple, that you have your data, you want to clean it, right? Okay. So suppose I'm working with uh, real world signal processing data, right? I am receiving signals from somewhere. I want to work with that data. Do you think that signals are like properly uh, proper there, right? No, definitely no. They require a lot of cleaning because there might be some noise, there might be something, right? So that stage should have to be there. So in that case, data preparation comes into the picture. You need to clean the data, you need to prepare. Human insight is also needed to tell different things about the data. You need, and sometimes what happens is that there is not enough data available, right? So you also need to have some simulated data. You need to have some artificially created data, right? So data preparation stage consists of all these steps. All of these you can do using MATLAB. Uh, and this AI workflow remains same whether you use MATLAB or not, right? So next is modeling, right? Now you have your data, you start modeling, right? You model your design, you tune it, okay? Then you have like you can have interoperability. So you might be developing some model there, but then you want to do things in MATLAB, so you interoperability comes into the picture over there, right? uh, then after model is made, right? Once the model is made, you want to test this model, right? So what you do is you integrate it with complex systems, you do some system level simulations, you do verification, you do validation, right? So all these things comes into the testing phase. Once all of these three steps are done, you have your model now, right? So it's ready for you. So you deploy it in different systems now. You deploy it in embedded devices, you deploy in enterprise systems, you deploy it in cloud, you deploy it on desktop, right? So you deploy it at different positions, right? Different places. So all of these things, I would say you can easily do with MATLAB and Simulink. Okay, you don't have to do individual things with every other software. So all these things can be easily done with MATLAB and Simulink. This workflow remains same. I'm repeating again, whether you are using MATLAB or not. Okay, so the four stages are, I'm repeating: data preparation, AI modeling, you do like make model, you test it, and finally you use it, right? So I hope everyone is clear with this workflow. And to make your models better and better, you do this iteration and refinement, that once the model is deployed, you collect data from it, you send it to data preparation stage, and you repeat all these steps again, again and again and again. It's a never ending process. Your like system just keeps updating itself, it's just upgrade itself. Okay, uh, I hope everyone is clear. So I hope we are not running short on time. Uh, so next we come to the regression picture, right? That we have a real world example. We have basically data of like cars, and we what we will do is uh, we will try to predict fuel economy that using that particular data, right? So how I will show you in MATLAB, you don't need to be a coding expert, you don't need to be a regression expert to do this particular thing, right? I'm quickly showing you the example in MATLAB. And I hope everyone is clear with whatever we have done till now. Uh, but I think we will be short on time if I continue. Pratnya, what should we do? Do you think should we like do regression now, example running now, or should we do it tomorrow?
Um, so I think we could do regression tomorrow with fresh, minds.
Sure.
That's my suggestion because, even if we start off now, I think we are going to be slightly over time, isn't it, Ayush?
Exactly. That's what I
So what
think.
I would suggest is we've done a good overview of MATLAB, Simulink, and MathWorks in general, and we have also done a very good intro about AI with ML and DL
Exactly.
specifically. So we could keep it open for discussion now and start off with the actual examples tomorrow, so that everybody kind of gets enough time to process today's information. That's my
Sure.
personal opinion, but if you think you have the time, you could decide accordingly as well.
Yeah. So I also think the same, since we are running short on time. It will not be a justice to do the example now. So what we will do is we will start with the example tomorrow. Everything will be like what I will say, most of the things, whatever we are going to do tomorrow, will be example based. It will less be lesser of a theory part tomorrow. So it will be great if you attend tomorrow. You will learn about regression, you will learn about classification, you will learn about clustering, you will learn about deep learning. Okay, so it will be great if you attend tomorrow. I'm just concluding what we did today. So we learned about MathWorks, we learned about using MATLAB and Simulink, different where MATLAB and Simulink is being used, different use cases. How can you get started with MathWorks account? How can you get started with MATLAB and Simulink? And then we have some basic differentiation of AI, ML, and DL. Uh, we understood about different ML techniques. We understood about difference between supervised and unsupervised learning. We understood what regression is, we understood what classification is, we understood what clustering is. So this is what we did today. Tomorrow, when you come back, what we will do is we'll start working with this simple examples, real world examples to get started with uh, these different things which we did today. Okay, so make sure that you attend tomorrow's session to get most out of what we did. So tomorrow, same time, we will be meeting 4 p.m. And before we leave, uh, there is still some time. So if you have any questions, you want to ask anything, you want to discuss anything, we are here for like next 5 minutes. You can go ahead and discuss with us. And just put in chat so that I will get to know, did you find this session helpful, or did you think it was just a waste of time for you? So it will be very helpful if we can get these things in the chat so that we can prepare accordingly for tomorrow's session.
Yeah, and just for the participants, information, we would be also sharing a feedback form with you tomorrow, and the link to it as well as the QR code would be shared with all the participants, specifically because it would help us, your responses would help us to make these sessions better. Actually, as we all know, virtual sessions are very difficult in terms of the interactivity part, and we at MathWorks put a lot of effort to kind of make this possible even with a large crowd, and most of us like connecting virtually, right? So um yeah, we're getting a few responses about the session being helpful, valuable, and being better than other virtual sessions. That's great to hear, right? So please take some 5 to 10 minutes out from your schedule tomorrow and fill up the forms and let us know which part of the session, including today's part, um, you most enjoyed, right? Or which was interesting or insightful, or you could use for your further uh, work with MATLAB Simulink, or just AI with any other tool. It could be anything else, but if it has added to your knowledge in any particular manner, please take some time off your schedule and fill the form for us. That would be a great help from your side. We would be in fact, using the responses to make our sessions better in future.
Second session you have tomorrow, so you don't have to hope for it. Yeah.
Yeah. Thanks, Ayush. Thanks, Pradanya, for the nice session. I hope like this is the one of the best session I have attended virtually, and a lot of good examples are there. People really enjoy it, and we have seen the count of participants remain consistent up to end for the 2 hours. This is really great. Thanks, Pradanya. You have nicely managed the queries in the backend, and I hope the tomorrow's session is also going to be great. And hopefully we have addressed all the queries for today's sessions. We'll meet you all tomorrow, but before that, we need a group photo with you all, just as you know, just as a memory. So I request you all to please on your video, and we'll take a short, group photo. Rupesh from my team, can you please take one? Kevin.
Also, I would like to say that it was very great to have people from different part of the world joining this session and learning. It's just great to see that particular enthusiasm you guys have. So thank you
Yeah,
for being in the
yeah.
session.
Parallelly, can you please type the country from where it belongs to, so that our speakers remain motivated, like, okay, the virtual session is really good. We are addressing multiple places by virtual sessions, and people are getting benefits of it. Just type your country names also parallelly. Oh, great. We are getting from Malaysia, Bangladesh, India. I have some people from Pakistan, India, Malaysia, China. Great. Pakistan, Bangladesh, India, Australia. Okay. So I hope you guys, Sri Lanka, I hope you guys are ready for the group photo. Uh, we have from Prague. Oh, please invite us to that place. Okay, I hope my team just please take one or two multiple photos. Okay, I hope it's done. Thank you so much, everyone. And this is really a nice session. And I hope that you guys will also come tomorrow at the same time, 4 p.m. IST, for one more interactive session, just a part of this same workshop only with Ayush and Pradanya. And thank you so much to be here. Thank you, Ayush. Thank you, Pradanya, for the nice delivery of this
Thank
lecture.
you. Thank you,
Thanks,
guys.
Thank you.
Rishi. Thanks for organizing this so well, and pre-event as well for being there and doing such a great job. So yeah, just on the note, on the ending note, I would like to say tomorrow we are going to do a lot of involved examples. Ayush is going to take you through some of the nice workflows for AI, which is going to really help you. It won't be like a seminar kind of a thing tomorrow. It is more going to be working alongside with you in MATLAB. So looking forward to see you all tomorrow.
Great.
Thank you,
Thank you.
everyone.
Thanks,
Thank
everybody.
you.
Thank
Thank
you.
Bye.
you. Thank you,
Thanks,
everyone. Bye bye.
Rishi. Bye.
Bye bye.
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 Take care.
Take care.